Anyway, so the announcement is here. Let me know if you have any questions. So any questions? Any questions for people that just joined the meeting? Any questions? All right. Okay. So today I want to finish up section 4.1. But let's recall what we did last time. So this section is about approximating the area under the graph. Approximating area under the graph of f of x. And then we talk about the left-hand sum and the right-hand sum. And the way I did was I drew out the graph and then find the left endpoints and then the right endpoints, compute the width of each rectangle, and then compute either the left-hand sum or the right-hand sum. But you can actually compute without drawing out the graph. Does anyone remember how to do it? So you compute the width of each rectangle by taking the length of the interval, and then you divide that by the number of rectangles. I'll write it down in a minute. So the width is the length of the interval divided by the number of rectangles. And then what about the height? So what is the height of each rectangle? How do I compute the height of each rectangle? So for each rectangle, how do I compute the height? The heights will be different for each rectangle, right? How do I compute the height? Okay, the y points. And you get that by plugging in the endpoints into the function. So I should write height plug endpoints into f of x. That will give you the height. So for example, given one interval, so the one interval would have two endpoints, right? Depending on depending whether you're computing left-hand point or left-hand sum or right-hand sum. If you're computing left-hand sum, you plug in the left endpoint, the endpoint on left, into the function to get the height. If you're computing the right-hand sum, you plug the right endpoint, the endpoint on the right, into the function to get the height. Does it make sense? Okay. Today we will do overestimate and underestimate. So this is the second thing that we talk about today. Overestimate and underestimate. So what's the difference between the two? We mentioned last time that overestimate means the rectangles should be over or under the graph. Over. So it should be over the graph. Whereas for underestimate, the rectangles should be under the graph. Okay. And then when computing the left-hand sum and right-hand sum, I say that you don't need to draw the graph, right? Because you can just plug the endpoints, either the left endpoints or the right endpoints, into the function to get the heights. But for overestimate and underestimate, you need to draw the graph. Now, here are some a few comments about left-hand sum, right-hand sum, overestimate and underestimate. In general, I mean, you might think that left-hand sum will be the same as underestimate and right-hand sum will be the same as overestimate, but in general, they are not the same. So right-hand sum might not be the same as underestimate. Right-hand sum might not be the same as overestimate. I don't want to write this down, but for increasing function and decreasing function, this might be correct. But which one is which? So for increasing function, left-hand sum would be the same as which one? Overestimate or underestimate? Okay, so for increasing functions, left-hand sum will be the same as underestimate. Right-hand sum will be the same as overestimate. For decreasing functions, left-hand sum will be the same as for decreasing functions, left-hand sum will be the same as okay. Left-hand sum will be the same as overestimate, and right-hand sum will be the same as underestimate for decreasing functions. I also say that I want to write this down. So whether you're computing overestimate, underestimate, or left-hand sum, right-hand sum, the width of each rectangle is always the length of interval. I need more space. Length of interval divided by the number of rectangles. So the question will tell you how many rectangles you need to take. So if it's 5, then you divide the length of interval by 5, and then use that as the width. And then I also mentioned that the number of endpoints should always be the same as the number of rectangles. Any questions? Okay. Let's look at one example. So let's say you have a function negative x squared plus 1. Find and overestimate and underestimate for the area under the graph of f of x from x equals -1 to x equals 1 using 4 rectangles. of equal width. So we're computing overestimate and underestimate. So I say that for overestimate and underestimate, you need to draw out the graph. What does the function negative x squared plus 1 look like? What does it look like? It's a parabola opening upward or downward. It's upside down. Vertex formula. So when drawing out a parabola, it's usually very helpful to draw out the vertex first. It's a parabola, so it's a parabola opening downward, so it should have the highest point. And using the vertex formula, you should be able to find where is the highest point. So recall that I guess it's called the axis of symmetry. For the parabola that looks like this, ax squared plus bx plus c. So this is a general function, general expressions for parabolas. And the axis of symmetry is given by x equals negative b divided by 2a. So what is a vertex? What is the axis of symmetry of the function in the question? So what is a, what is b, what is c? Okay, a is, I'm looking at two numbers. Okay, a should be -1. So a is the coefficient of x squared, which is -1. B should be 0. So the vertex for our function is x equals 0. Does it make sense? Because when b equals 0, the vertex is 0. All right, so now you know that the highest point is x equals 0. And because the parabola is symmetric, so it should look like this. Is it okay so far? And I also know that negative x squared plus 1 has two x-intercepts. How do I find the intersection points with the x-axis? How do I find these 2 points? Okay, you set y to be 0. X-intercepts. 0 equals negative x squared plus 1. So x squared equals 1. And so x equals plus or minus 1. This is -1, this is 1. Is it okay? Yeah, I have 0. Any questions so far? Okay. Now, what is the next thing? How many rectangles are how many rectangles do we need? We need 4 rectangles. So it says here that we need 4 rectangles. So let's compute the width of each rectangle. Actually, let me start new page. So the width of each rectangle, delta x, remember that that's a length of interval divided by the number of rectangles. What is the length of the interval? We are going from -1 to 1. So what is the length of the interval? Yeah, 2. So you do 1 minus -1. That's 2. And then the number of rectangles should be 4. So that gives you 2 over 4, which is 1/2. Question? Okay, now that you know that each rectangle should have width 1/2, you can now split the interval into several parts. So starting from -1, that's the first point. The second point should be -0.5, -1/2. And then the next one would be 0. And then the next one should be 1/2 or 0.5. Does it make sense? Okay. And let's say we want to do overestimate first. So let's do overestimate. For overestimate, let's use green. For overestimate, what do we do? So focusing on the first interval between -1 and -0.5. Which one is the highest point? And remember that overestimate, for overestimate, I need to pick the higher point of the two. So -1 and -0.5, which one is higher? -0.5. So your rectangle should look like this. Does it make sense to everyone? Okay, between -0.5 to 0, which one is higher? 0 is higher. So the next rectangle should look like this. And then between 0 and 0.5, it's again 0. 0 is higher. And then for the last one, 0.5 and 1, it's 0.5. Is that okay? Okay. Now let's compute the overestimate. So for each rectangle, the area would be the width multiplied by the height. The width is always 1/2. That's what you computed here. The height, it would depend on the endpoint. So for the first interval, we pick -0.5 because that was the higher point between the two. So you would do 1/2, which is the width multiplied by the height. And you get the height by plugging -0.5 into the function. Make sense? That's the area of the first rectangle. And the second rectangle, again, the width is always 1/2. Multiplied by the height. And for the second rectangle, I'm using the 0 point because 0 is higher here. So you plug 0 into the function to get the height of the second rectangle. And do the same for the third rectangle and the last rectangle. So for the third rectangle, you plug again 0. And for the last one, you plug 0.5. Questions? Any questions? Okay. The next thing you do is to plug, just to compute all these values, so plug all the points into the function and then compute them. And you should get 7/4. All right. And let's do underestimate. So for underestimate, how did you get 14/4? Uh-huh. So if you add those numbers up, you should get 3.5. And so the number you get should be 3.5 divided by 2, which is the same as 7/4. I don't actually understand your question. Yeah, 7/4. And for underestimate, let's look at the first interval. So between -1 and -0.5, which one is lower? So underestimate means all the rectangles should be below the graph. Which one is lower? -1 or -0.5? -1. So your rectangle should look like this. It's just a line. And between -0.5 and 0, which one is lower? -0.5. So the rectangle should look like this. And then between 0 and 0.5, you're picking 0.5 because that's lower. And then 0.5 and 1 is lower. So right here. So you actually need to just compute the areas of the two rectangles in the middle, because the other two will be 0. Again, 1/2 times the width multiplied by the height, and the width is always 1/2. And then, so for the first one, the height is just 0. For the second one, we need to plug -0.5 into the function. And for the third one, you're plugging in 0.5 into the function to get a height. And for the last one, the height will be 0. And if you compute that, you're going to get 3/4. Does it make sense? Question, why would it be 0? This is a line. right? The first interval between -1 and negative 0.5, that's a line, right? And so the area of the line should be 0 because it doesn't have any height. When I say it doesn't have height, means the height is 0. Is that okay? Okay. Okay, so now we compute. So I computed the overestimate to be 7/4, and then the underestimate to be 3/4. What can you say about the exact area under the graph? So if I ask you to use these two numbers to describe the exact area under the graph, yep, overestimate means that you're overestimating the area. Underestimate means you're underestimating the area. So the area, so note that the exact area is between 3/4 and 7/4. Questions? All right. Before I move on to the next section, next topic, one last remark. So when doing the estimation, what happens when I take more and more rectangles? What can you say about the estimation? Okay, so the more rectangles I get, the more rectangles I use, the more accurate my estimation would be. Um, I'll come back to this maybe in the next section. So eventually you want to take the limit of the number of rectangles goes to infinity, but we'll come back to this next week. Any questions before I move on to the next topic? Okay. So this is section 4.1, part 2. It's called sigma notation. It's not as scary as it sounds, and you see that in a moment. So here's the notation. So when I write this sigma, so when I write this as expression, I mean, this is a notation for the summation of the numbers of all the QIs. And you want your I to go from M to N. So let me write this. So this notation is called sigma. It means the summation. And the I is the index of the summation. And when I write at the bottom I equals M, it means I starts from M. And when I write the top is N, I mean I goes all the way up to N. So it starts from M, goes all the way up to N. So this is expression right here, it means that I start from I start from I equals m, so you do q sub m plus qm plus 1 all the way up to qn. Let's look at one simple example, and you get what I mean. So let's say I want to compute this. So I wanna add up all the numbers that look like this, and I goes from 2 to 4. The way you do is you plug all the numbers in your index set into the thing that I just circled. So you start from 2. That means I need to plug 2 into the function, so I get root 2. The next one will be 3, so root 3. The last one is 4, so root 4. Make sense? Yes. So how would you enter into? You just enter root 2 plus root 3 plus root 4. Second example, sigma of 3, and then I goes from 1 to 5. So when I equals 1, the number you get is, does it change at all? No. So this thing right here, it doesn't depend on the index set. So that means whatever I put in, it doesn't change. So when you plug I equals 1, you get 3. When you plug I equals 2, you get 3. When you plug I equals 3, you get 3. When you plug I equals 4, you get 3. And when you plug I equals 5, you get 3. And then you stop. Is it okay? What about this? So sigma of 2i minus 1, I goes from 1 to 3. So when you plug 1, you get 2 times 1 minus 1. When you plug 2, you get 2 times 2 minus 1. When you plug 3, you get 2 times 3 minus 1. Questions? Any questions? Okay. So let's look at this web problem here. So this is web work. Let's see. 4.1 part 2, question 3. So it's asking you to express each of the following sums into sigma notations. So I have 4 plus 8 plus 12 plus 16 plus 20. And I want to write that as sigma I goes from 1 to 5 of something. So do we see any pattern here? So 4, 8, 12, 16, 20, what is the pattern here? It adds 4, so it's a each of them is a multiple of 4, right? So you would expect this to be 4 times I. Because when I equals, so for example, when I equals 1, you get 4 times 1, which is 4. And that's the first term. When I equals 2, you get 4 times 2, which is 8. That gives you the second term. I equals 3, 12. I equals 4, 16. I equals 5, 20. So this is the correct answer. Does it make sense to everyone? Okay. Part B. 4 minus 8 plus 12 minus 16 plus 20. And you want to write that as sigma I goes from 1 to 5 of something. What is the pattern here? So 4, negative 8, positive 12, negative 16, positive 20. What is it? Well, not really. So, no. Okay, so let's look at Zach's expression. So negative 4 times I. When I equals 1, you get negative 4 times 1, which is negative 4, which is not the same as 4, right? And for Ryan's answer, negative 4 times I to the negative 1, that's not correct either. You can check, for example, I equals 2. Negative 4 minus I, not correct either. When you plug I equals 3, you get something. Not that either. So this is actually, um, um, okay, I'll tell you what to do, and then you try to think about what part C should be. So for part B, I mean, so without the plus or minus, they all look like 4 times I, right? Do we agree on that? That's the same as part A. So without a plus or minus, it looks like 4 times I. And I want to be able to adjust the plus or minus. So I need to multiply by negative 1 to the something. So let's see what happens if I put in my I here. So when you plug I equals 1, you get 4 times y is 4. Negative 1 to the first should be negative 1. And when you multiply these two together, we get negative 4, which is not the same as 4. So I is not correct. What you can do is you can try I plus 1. So let's check why this is correct. So when I equals 1, this is correct. When I equals 1, you get I plus 1 equals 2. Negative 1 to the second is positive 1. So 4 times positive 1 is 4, which is correct. Does it make sense? So the second thing right here, it actually tells you whether it's positive or negative. Is it okay? So I'll let you figure out part C. So part C should look very similar to this, but I'll let you play around. If you have any questions, let me know. Okay. We have 5 more formulas. So this first one is more like summation rules. It tells you what you can do with the summation and what you cannot do. So if I want to sum up the numbers qi plus pi or minus pi's, because I'm doing the summation, so I can always split them up like this. And let's say I'm taking the sum of c times qi, and c is a constant. So whenever you have a constant that doesn't depend on the index, the I, you can always pull that out of your summation like this. Is it okay? All right. Basic summations formula. So I think you only have one web work. I didn't get the second part. Okay. So this is like saying, how should I say this? So let's see, 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. So this is, so let's look at one example, 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. They all have the common factor 2, right? And so you can pull out the 2 and say that this is 2 times 2 plus 3 plus 4 plus 5. So all I did was I pull out the common factor here. And that's exactly what the second condition, the second rule is saying. Questions? All right. So I think you only have, the next thing I want to do is tell you there are three other summation formulas that you need to know. And I think there's only one web work question that you have to use this. But in the next section, this will be really helpful. So what is a summation? What is a sum of 1 when I goes from 1 to n? So how many ones do I have? You have n of them. So let's check what is true. So when I equals 1, you get 1. When I equals 2, you get 1. When I equals 3, you get 1. So on and so forth, all the way up to n. So this will be the same as n. Make sense? And the second formula, I'm not going to prove that. You can search it online if you want. So the summation of I, this works for any constant, right? Yes. We'll talk about that in a second. So the summation of the summation of I goes from 1 to n. So this is actually the same as saying 1 plus 2 plus 3 plus 4 plus 5 all the way up to n. The formula is n times n plus 1 divided by 2. We also have the formula for the sum of squares. So I want to sum up the square of numbers going from 1 to n. So I want to do 1 square plus 2 square plus 3 square, 4 square up to n square. The formula is n times n plus 1 times 2n plus 1 divided by 6. Questions? All right. By the way, I should mention that these formulas, they only work if you start from 1. You have to start from 1 for this to work. And we'll see in a second if it doesn't start from 1, what do we do? But yeah, let's see this first example first. So the summation of 3, I goes from 1 to 10. This should be. So how many 3s do I have? 10 of them. So when I equals 1, you get 3. When I equals 2, you get 3. I equals 4, you get 3, all the way up to 10. So this one should be 3 times 10 equals 30. Question? So let's say I want to take the sum of negative 4 times I squared. I goes from 4 to 10. What do I do? So what can I do? What I can do is the negative 4 is a constant. Yes, but n times 1 is the same as n. You're talking about this one right here, right? It's n times 1, which is the same as n.
Yeah, but like if we're writing a basic formula, shouldn't it be n times that constant value in front of the sigma? So whatever that, like if that one was a 2, it would be 2n. If that one was a 10, it's 10n.
Yep, yes, but I'm writing 1 in my formula, so in my formula, this is 1, but you're right. So if it's 3, then it's 3 times n. If it's 5, then it's 5 times n.
Okay. Yeah, it caused a misconception when we were going to do the example, because then I was like, well, what do you do with like I agree it should be the 3, but based on the formula, you can't multiply it by 3 because it's just n. It should be 1
Yes.
times n.
Yep. Any other questions? So for this example right here, negative 4 times I squared, negative 4 is a constant, so I can put that outside of the sum and get negative 4 times this guy, I squared. Does it make sense? So this is one of the properties that I mentioned before. This is a constant that doesn't depend on I, so I can pull that out outside of the sum. And now look at this sum here. So it goes from, it's a sum of squares, but it goes from 4 to 10. What do I do? It doesn't start from 1, so what do I do? Okay, I guess I can do that, but if I'm asking you 4 to 100, what do you do? Or 1000? You don't want to just plug in, right? Because you'll be plugging in crazy amount of numbers. You can still use the formula, but you have to do some trick. This is a summation from 4 to 100. The formula is a formula for the sum from 1 to n. So what you can do is you can first sum from 1 to 100 and then subtract the first three exactly. So I would write -4. I goes from 1 to 100 of I square minus, because I need to start from 4, so you need to subtract the first three. So 1 to 100, and then you subtract the first three. And now you can use the formula. So for the first part, you're summing from 1 to 100, so your n should be 100, and you're using the last formula here. So plug n equals 100 into your formula, you get 100 times 100 plus 1 times 2 times 100 plus 1 divided by 6. That's the first one. And for the second one, what is my n? So for the second sum, what is my n? For the second sum, what is my n? 3. Okay, so you plug in 3. You plug 3 into your formula here. The third one, the last one, you get 3 times 3 plus 1 times 2 times 3 plus 1 divided by 6. Is that okay? Any questions?